of self-incompatibility, right? We can have gametophytic. I guess I should write this down. Right? Oh man, I can't avoid the overhead no matter how hard I try, apparently. Right, we have gametophytic, right? Wow, I'm just literally doing this from memory, so this is fun. So gametophytic, right, is where the incompatibility is determined by the haploid spore, or the haploid pollen grain that lands on the stigma. So if the it's determined, right, by the haploid. So if you have a pollen grain that is an S1 type, right, and it lands, for example, right, and it lands on an S1, S2, right, stigma, right, the stigma is going to recognize this self-ing, right, and it's going to reject it, right? It's actually going to produce a RN, it's called an S, I'm literally doing this from memory right now. It's producing an sRNase, which interferes with the ribosomal RNA of the pollen tube, right? Right, okay, thanks guys. That's gametophytic, right? So it's only determined by the haploid identity of the pollen, okay? That's because it's different than the other one, right? So thus, if I were, just big picture, right? Different species of plants employ different strategies to prevent selfing, right? Some of them engage in the gametophytic kind, some of them engage in the sporophytic kind, okay? So if a plant engages in the gametophytic variety, right, that means that if an S1 pollen grain from that species, so S1 can fertilize anything that doesn't have an S1. So it could do like an S2, S3, etc. Just not an S1 allele. That's the gametophytic, right? Determined by the gamete, by the male gamete. However, you can also have sporophytic, right? Phytic, which is a little more complicated and seemingly, I think it's less common. Don't quote me on that. So when we have sporophytic, right? The incompatibility is determined by the parental diploid alleles, or genotype, right, of the male sporophyte. What does that mean? That means that this is what I meant about we're getting back to the wall of our pollen grain, right? In certain species, right? We have our pollen grain, right? Here's our generative cell. Here's our tube cell. We've got this little coat, right? In these types of plants, it is the 2N, right? The diploid identity, which somehow is recognized in this coat. I don't know the mechanism of it, right? But it recognizes the diploidy of the male sort of parent of the pollen. Meaning, even if this individual, right, this is haploid, right, so it could be S1, but somehow, when it lands, right, here, this one is going to recognize both parental alleles, meaning that it's going to know, say, that it came from an S1, S2 parent, whether it has the S1 allele or the S2 allele. It's going to know what the parental genotype was, and it will respond thusly. So, if S1 pollen from an S1, S2 sporophyte, right, so its parent was an S1, S2 genotype, right, tries to pollinate an S2, S3, what will happen? blocked, denied. Not going to happen, right? Because somehow, even though it is the S1 gamete, right, it recognizes via the coat of the pollen grain that it came from an S1, S2, right, parental genotype, and it will reject it, right? Versus if this were gametophytic self-incompatibility, right, if this S1 landed on an S2, S3, it would be good to go, right? But this plant, this species, engages in sporophytic incompatibility, meaning it's a lot pickier, pretty much, right? It's like, I don't care what you are, I know what your mom was, and I don't want to right? I don't care if you have, the S1 allele, I know that your other parent had the S2, so we're incompatible. There seem to be lots of theories about the codominance being a little more prevalent in these types of things. Don't worry about it, but right? I feel that the book does not do a great job of making it clear that these are two separate processes that occur in different species, right? It's not like the plant does both. It does one or the other just based on which species it is, right? So when we're dealing with gametophytic, right, it's only determined...
Gametophytic or sporophytic? Sorry.
What?
Oh, sporophytic, sorry.
Thank you.
You're welcome for something I have no idea.
Being beautiful.
Oh.
Nice.
You don't get extra credit, though.
Because then you'd all get extra credit, right?
Oh.
No.
For thinking I'm beautiful, not beautiful. Yeah.
Nice ego boost.
One day you too can be a TA in college. Intoxicated. Right, so when we're talking about our gametophytic self-incompatibility, right, we are only concerned with the allele of the gamete, right? We're only concerned with whatever haploid allele we're finding in our pollen, right? So if it's S1, it's good to go as long as there's not an S1 on the female plant it lands on, right? So it's a little more right thing. And this is the one we actually know the pathway for. The way it shuts it down is it actually starts to grow. Right? It doesn't immediately block it. It starts to grow. And it actually occurs in the style portion where it actually shuts down the pollen tube growth. Yes?
I was just about to ask, at what point does it stop it? Mm-hmm. So it doesn't get to the point where, it fertilizes anything.
It doesn't get close to our ovule. It doesn't get close to our embryo sac. It makes it a little ways down the style, right? And then in this gametophytic form, it interferes because the sRNAs, which interferes with the ribosomal RNA of the pollen tube, right? So it stops making it. That makes sense, right? And so again, right, in the sporophytic form, we are not only concerned with the allele contained in the pollen, we're concerned with the parent from which it came, right? So it's going to somehow recognize via the coat that it came, it's going to somehow know both alleles of the parent sporophyte of that pollen grain, right? And it's going to shut it down, right, if it has anything in common.
You're one.
Okay.
How does it do, is it also reproductive growth?
I have my cup.
It does. I don't think we know the mechanism for it, or it wasn't.
So does the tube actually start growing?
It does, yeah.
Yeah.
Yep. As far as I know. Starts growing, but it doesn't actually make it all the way down. Right? That's why we don't call, that's not fertilization when the tube starts growing, right? That's still part of pollination, essentially, right? It's not fertilization until we get up in that micropyle, right? Okay. Whoa, that was really exciting. This is why I don't make PowerPoints, because clearly this is not meant to be. So, okay, so there we go. Let's wrap this up really quickly. I think that was the thing people care about the most. Are there any other questions about self-incompatibility? Okay. We have totipotent cells, right? This is sort of this phraseology seems like it's falling out of favor, so I don't worry too much about this, but they can asexually generate, right? We have, this is more talking about farming and stuff like that. Just review this in your book. I'm way over time, but I know you guys are probably starting and hating me. We can graft things. No one cares. I kind of don't really care about this. You can clone a garlic plant. Yay, right? Okay. We can do, this is kind of interesting, right? We can engineer things and get rid of plant viruses, right? Right, and we've been fucking with plants forever. Right, that's corn. That's corn. That's like way, this thing cannot thrive on its own in the wild, right? That is what OG corn looked like. So, right, we've been breeding things, we've been artificially selecting for mutations, right? So one of the things they do is they actually sort of try to introduce these transgenic organisms. This is very controversial stuff because we don't quite know how it works, and there's a lot of concerns. But where's my picture, right? This special kind of rice and certain types of cassava that they have to try and address vitamin deficiencies in certain poor parts of the world. But there's a lot of concerns about the, proliferation of these. Biofuels, you didn't even talk about this, right? Debate about GMOs, we've all heard this in the news. I really want to finish. I mean, they argue some of them have health benefits. I think we know who's funding this textbook. Right? Burn. Right, because basically what can happen, right, it can get out and hybridize just with things that are physically near it. And this has happened a bunch of times. Right.
It frightens me.
Yay, we're done.